Hello world, welcome back to the channel. Today I'm reacting to Google latest drop, an offline AI model called Embedding Gemma. Now, as a software engineer, I've seen plenty of hype around AI models, right? But this one caught my attention because it's small, fast, and runs completely offline. That could change how we build apps for phones, laptops, and even private enterprise systems, right? So I'm going to give you my raw unfiltered take, what's exciting, what's just marketing fluff, and whether I think developers like us should actually care. Let's get into it.
Google has just unveiled a new AI model that's breaking expectations about what small models can do. It's called Embedding Gemma, and while it weighs in at only 308 million parameters, it's delivering results you'd normally expect from models twice its size. It runs fully offline on devices as small as a
Okay. So just Google just dropped a new AI model embedding Gemma, 308 million parameters. That's tiny compared to the LLM monsters we are used to hearing about, right? Let's see if this is hype or actually useful. You never know. It actually may be useful.
phone or as simple as a laptop, and still manages sub 15 millisecond response times on specialized hardware. On top of that, it understands
Okay.
over 100 languages, tops the benchmark charts under 500 million parameters, and plugs straight into all the major AI frameworks people are already using. The headline that grabbed everyone is the size and speed. Embedding Gemma has 308 million parameters, with roughly 100 million in the model's brain and about 200 million in the word lookup tables. With smart training and quantization, it runs in under 200 megabytes of RAM, which is small enough for
Yeah.
everyday devices. And there's a hardware stat that matters too. On Google's Edge TPU, it can create an embedding for a 256 token snippet in under 15 milliseconds. Essentially, responses pop up fast, which is the difference between
They are saying it runs fully offline on phones and laptops with sub 15 millisecond response times. Wow, that's insane. I'm already thinking about use cases, right? Offline assistance, secure company data, and even developing countries with poor internet, human. If this really works, it's actually a game changer in the industry. Yeah. Wow.
a feature you use constantly and one you ignore after the first try. Now, where it really earns its place is quality. On the massive text embedding benchmark across English and multilingual tracks, this model ranks at the top for anything under 500 million parameters. It was trained on over 100 languages, so it doesn't fall apart when you mix English with Spanish or German or anything
Yeah.
else. The idea is simple. You want small and fast without giving up accuracy, especially when you're doing retrieval augmented generation, where a search step finds the right passages and a generator writes the answer. If the search step misses, the answer will sound confident and still be wrong. This model is built to reduce those misses. The foundation here is an encoder.
Now they are talking about quality, right? Embedding benchmarks, multilingual performance. Honestly, this is where small models usually fall apart, right? But if it's topping the charts under 500 parameters, that's huge, right? I've worked with embeddings before, and the biggest pain is accuracy. If such misses, your entire pipeline collapses. So that's a very key feature to add onto it. So Google focusing here makes a lot of sense. Yeah.
Architecture from Gemma 3, but adjusted for this task. So instead of reading left to right, like a typical chatbot brain, it reads the whole sentence at once with bidirectional attention. That gives it a better sense of overall meaning, which is exactly what you want for embeddings. It can take up to 2,048 tokens at a time, which covers a lot of paragraphs in one shot. Then it squashes everything into a single vector, a fixed length list of numbers that captures the meaning. By default, that vector has 768 dimensions, and it's normalized so comparisons behave well. Now, here's a neat trick that keeps storage and speed in check. The model was trained with something called Matrosha representation learning. That lets you shorten those vectors to 500.
Bidirectional attention, 762 dim vectors and the ability to shrink dimensions without retraining. That's engineering magic. So many people are trying that, right? For anyone who's built vector databases, storage adds up very quick, right? Dropping to 56 dims with minimal loss. That's the kind of optimization devs actually need, not just fancy, very picked benchmarks, right? Yeah.
112, 256, or even 128 dimensions without retraining and without losing much quality. So if you're indexing a lot of files on a phone or you're trying to keep a database tiny and fast, you switch to the smaller size and still get strong results. You can start with 768 while you test, then drop to 256 for production to cut memory and disk use. Also, a big focus here is running privately and fully offline. Embedding Gemma was built to run locally, and it shares a tokenizer with Gemma 3N, which keeps the pieces in sync when you pair them. That pairing matters because a classic flow goes like this. Embedding Gemma finds the best passages from your documents, then Gemma 3N writes the response using only those passages. If you want a fully offline assistant that respects your data, this is how you do it. You can search across files, texts, emails, and notifications.
Here's the privacy angle, right? Fully offline, no cloud dependency. That alone is a selling point. Just that, right? Imagine your phone searching emails, files, and chats without ever leaving the device, right? That's exactly the opposite of how big tech usually works. And I like it.
Without sending anything to the cloud. You can classify user requests into function calls for a mobile agent that runs on the device. You can build a private knowledge bot for a small team, and it keeps working on a flight with no Wi-Fi. The ecosystem support is wide, which makes life easier. The weights are already on Hugging Face and Kaggle, and you can use them on Vertex AI too if you want to run it locally. Ollama installs it with a single command. LM Studio gives you a quick way to test it, and Llama CPP compiles it into a lightweight version that runs easily on most machines. On Apple devices, MLX makes it work smoothly with Apple Silicon. And for the web crowd, Transformers.js lets you run it directly in the browser. That's how the Hugging Face team built their demo, where you can see sentences mapped out in 3D right on your screen. If you need something more portable, there's also an ONanX runtime package, so you can plug it into projects written in Python, C, or C++ without extra hassle. Let me drop this in real quick. There are two kinds of people right now. The first group is using AI to create income streams that run on autopilot, and the second group is sitting on the sidelines watching it happen. I'm about to reveal something I call Faceless Empire. A method that lets regular people generate $3,000 to $5,000 a month without showing their face on camera, without special skills, just by letting AI do the heavy lifting. And here's the catch. Only 200 spots are opening for early access, and they'll disappear fast. This isn't about quitting your job or grinding 10 hours a day. If you've got a couple of hours a week, you can start building a side income that actually scales. Don't be the one who waits while others build their empire. The early adopter advantage won't be around for long. Hit the link below to join the list and be the first to see the full system when it drops. Now, pretty much every...
Okay, wait a second. Faceless Empire? Oh boy, here comes the internet guru ad break, right? This part always kills me. They drop a cool AI update and then sneak in a get rich with AI course. Classic YouTube. Biz is biz.
Popular AI frameworks already support embedding Gemma out of the box. Sentence Transformers handles queries and documents easily. LangChain and Llama Index plug it into vector databases like FACE, and Haystack or TextAI work the same way. If you'd rather run it as a service, Hugging Face offers text embeddings inference with simple endpoints. And the CUDA builds are ready for GPUs from Turing all the way to Hopper. One thing you shouldn't overlook is how the model handles prompts. When it was trained, it actually learned little prefixes that tell it what kind of embedding you want. For example, if you're doing retrieval, queries start with task, search result, query, while documents start with title, none, text. If you're using sentence transformers, it takes care of that automatically when you call the right methods. But if you're working in another framework, you'll need to set those prefixes yourself.
Back to the tech, Hugging Face, LangChain, Llama Index support. That's what I wanted to hear, right? If it's already integrated into the ecosystem, I can spin up a POC I can spin up a POC this weekend, right? And those prefixes, that's a neat detail. Little hacks that make embeddings actually accurate. Miss those and your app's useless, right? Yeah. So those are very key details.
Fixes yourself. If you skip them, the model will still try, but the accuracy drops because it doesn't know exactly what you're
Yeah.
asking for. The training setup is pretty big, around 320 billion tokens from web text, code, technical docs, plus some synthetic examples to cover specific tasks. The team filtered out low quality and sensitive data, including strict safeguards against CSAM. To keep things fair, models that trained on more than 20% of the benchmark set don't count on the leaderboard, so no one can cheat with overfitting. Even with those rules, Embedding Gemma still holds the top multilingual spot, under 500 million parameters, and posts strong English results too. If you want to adapt the model for a specific job, it's actually not that hard. Hugging Face tested this with medical data using a data set called Myriad. They took the base Embedding Gemma and fine-tuned it on a regular RTX 3090 graphics card. The whole process, about 100,000 examples, finished in just 5.5 hours. The results jumped from a score of 0.834 to 0.886, which is a big deal in a field where every bit of accuracy matters. What's more, that smaller tuned model ended up beating bigger, well-known models. It's a good signal that you can get real gains by adapting the model to your field without burning weeks of compute. Looking at the bigger picture in Google's
Training on the 20 billion tokens, but still running under 200 MB RAM. Respect. Respect. And fine tuning in 5 hours on a 3090. That's practical. I hate when papers say fine tuning is easy, but then need eight hundreds for 2 weeks, right? I hate that, right? This sounds this sounds actually doable, right? Yeah, this is actually perfect for developers.
lineup, the roles are now pretty clear. Embedding Gemma is the one you reach for when you care about privacy and offline use. Gemini embeddings, on the other hand, are there when you need top-tier quality at massive scale running through the API. That simple split keeps it obvious which tool fits your project.
Yeah.
Google also smoothed out the developer experience. The same tokenizer as Gemma 3N keeps retrieval pipelines consistent. The weights are openly available under the Gemma license, and the docs even include a quick start RAG guide in the Gemma cookbook. On top of that, Hugging Face built a live browser demo that lets you literally see how sentences cluster, which makes the concept click even for
So Google is basically saying use Gemma embeddings if you care about privacy and offline use. Use Gemini embeddings if you want max cloud skill, right? Honestly, I like this clarity. I like this clarity because developers hate guessing which tool to pick, right? So they are actually considering developers here.
non-technical folks. It's clear this model was designed with actual use cases in mind, not just benchmarks. It's small, efficient, multilingual, and already plugged into the tools people actually use. You get privacy-friendly search on a phone, responsive RAG pipelines on laptops, and fine-tuning paths that don't demand a supercomputer. It's a rare case where the release
Final thoughts. I think this actually feels practical, right? Not vaporware, not just cherry-picked benchmarks, right? A real model I could deploy today. Of course, I want to test it myself before drinking the Kool-Aid, but this is one of the first Google AI drops that feels genuinely useful and out of the box. Yeah.
feels practical from day one. All right, here's your moment of truth. You can wait for the perfect time or you can act now. Faceless Empire is the system behind my $500,000 AI business, running on autopilot. Only 200 founding spots are opening, and once they're gone, they're gone. Don't get left behind. Click the link below and lock in your place before it disappears. So here's the question. Do you think smaller offline models like this are the future, or will cloud giants still dominate? Drop your thoughts in the comments. I'd love to hear them. Don't forget to hit subscribe and leave a like if you found this interesting.
So smaller offline models like this, are they the future? Uh, I'd say yes, at least for edge devices, privacy-focused apps, and companies that can ship data to the cloud, right? Cloud giants won't disappear all of a sudden. But offline, fast AI, this is the beginning of something big. Anyways, that's my raw take as a software engineer. If you are also building with AI, drop a comment. Are you team offline or team cloud, right? Do you prefer offline or cloud, right? And yeah, catch me in the next one. Keep winning. And also, please subscribe. Yeah.